Okay, good morning class. Right, so we continue, okay, our previous session. Okay, so first, before we answer the question, right, so we see about the passive immunity and also active immunity, okay. Right. So immunity can be classified into two types. Okay. So passive immunity and also active immunity. So both immunities can be obtained naturally or artificially. Okay. So first one we see about the passive immunity. Okay. So the body gains antibody from external sources. Okay. So passive immunity, right? The body gains antibody from external sources. So they are divided into two types, okay, natural and also artificial, right? So the natural passive immunity, okay, so that one is we obtain, okay, when a baby receive antibody from breast milk or from the mother's blood that flows across the placenta. Okay, so this immunity is only temporary and also short-lived. Okay, so last from a first few months after the birth of the baby. Okay, so you can see right here the graph. Okay, so it increase. Okay, so when the baby feed the breast milk from the mom, okay, so the antibody will increase. Okay, and we sustain about a few months here, and then gradually it will be decrease. Okay, so this one is only temporary. So this is a natural passive immunity. So natural because we obtain it naturally from the breast milk or from the mother's blood. Alright, and then the first one is the artificial passive immunity. Okay, so obtained when an antiserum is injected into the patient body. So this antiserum, okay, we fight against the pathogens without interrupting the patient's immune system. So what is actually the antiserum? So antiserum is a clear liquid in the blood that contains antibody to prevent disease. So this one is only also fast, okay, and it's also temporary. Okay, so you can see here, so we inject the antiserum in the body, so you can see it increase. Okay, and then after some time, it will be decreased. So later, after we inject the second time, okay, it increase, then gradually it will be decreased. So this one is also temporary. Okay, alright. The next one we see about the active immunity. Okay, so the active immunity is the body produce its own antibodies. Okay, this one we get from the external sources. Okay, from the outside, right? But from this one, okay, it comes from our body. Okay, so the body produces its own antibodies when stimulated by antigens. Okay, so it divides into two, natural and artificial. So natural active immunity, because it occurs when a person recovers from an infection. Okay, so the immunity lasts long after the infection. Okay, so this one lasts long, okay, compared to this one. This one is only temporary. Okay, so during the second time of the, let's say the person got the first infection. Okay, so after that it will become immune. So during the second time infection, the antibody produced exceed the immunity level and immunity is achieved. Okay, so during the first infection, the antibody produced it at a low level and does not achieve the immunity level. Okay, so at the first infection, so the body produced antibody only a minimum level. Okay, only a minimum level, and it does not enough, okay, to achieve the immunity level. But second time, okay, so because the body knows, so this one is not enough, so it will produce the higher antibody, okay, higher than this level, so it will become immune. Okay, alright, so the next one is the artificial active immunity. So occurs when a vaccine that is contain a dead, okay, or weakened pathogen is injected into the body, and the immune system respond by producing antibodies. So the immunity lasts long after the infection. So this we use the vaccine. Okay, so actually the vaccine is the dead or weakened pathogen. Okay, so that or weaken pathogen that is injected to our body. Okay, so the body, okay, will produce the antibody, okay, to kill the pathogen, right? So here is the first vaccine injection. So you can see the antibody increase. Then we inject the second one, it will increase higher. Okay. So and then it reach the immunity level. Okay. So you have to remember the first one is a natural passive immunity. Passive means it get from the external source. Okay, it's not produced by our own body. So the natural one is come from the breast milk or from the mother's blood. Okay, actually this one is for babies. Okay, and then it's only temporary. Okay, and then the second one is the artificial passive immunity. So this one, the anti-serum is injected to our body. Okay, so this anti-serum will fight against the pathogen. Okay, and it only also temporary only. Okay, and then the second one is the natural active immunity. So this one is produced by our own body. Okay, so by the antibody. Okay, so this one, the natural one. Okay, so this one, if let's say we have a first let's say we have a chicken pox, right? Okay, so usually we only got once. Okay, so because our body already got the immunity, okay, body we already produced the antibody. Okay, when the first time we have a chicken pox, okay, so the body produce the antibodies, but it's not enough. Okay, only a low level. So if second time, so the body already knows, right? So this the amount is not enough, so they will produce higher. Okay, so this that time we reach the immunity. Okay, so the example is like we have a chicken pox. Okay, and then the second one is the artificial. So artificial is actually the vaccine. Okay, so the vaccine is actually the death of the weak of the pathogen that is weak, okay, that we injected into our bodies. Okay, so then the antibody will be produced, okay, to kill the pathogen. Okay, so this one, both of these, the active immunity usually is last long than the passive one. Okay. So let's go to the next slide. So that this one, the question asks you, the diagram 1.1 shows a type of cell found in the human body. Okay, so this is actually a white blood cell. Okay, white blood cell. Okay, state the function carried out by the type of cell. So I think on Tuesday, okay, I already explained what is the function of the white blood cell. So white blood cell usually is produced by to produce the antibodies and also carries out the phagocytosis to kill a pathogen. So what is a phagocytosis? Phagocytosis is a process, okay, where the white blood cell will digest the pathogen, okay, that come into our body, okay. So this is the function of the white blood cell. Okay, so the next one is diagram 1.2 show two graph of immunity. So complete the boxes in the diagram 1.2 shows using the type of immunity given. Okay, so this one you can see is only less temporary. This is actually for the pathogen. Okay, sorry, for the anti-serum. Okay, so artificial passive immunity. Okay, so the first one is artificial passive immunity. So you already know because it's actually this drug is only lasting or temporary, right? So temporary must be passive. Okay, passive immunity. Okay, for this one, okay, this one is natural active immunity. Okay, active immunity because you can see is long lasting. Okay, so this one is like the first one. Okay, the first graph here. Okay, so occurs when the person recovers from an infection. Okay, so natural active immunity. Okay, so that is the answer for this one. Okay, next one. Okay, state the meaning of immunity. So what does it mean by immunity? So immunity is the ability of the system of the body to fight pathogen when the body is infected by it. Okay, so the ability of the system of the body to fight pathogen before the body is infected by it. Okay, so this is the meaning of immunity. Okay, C. An epidemic has spread in a town. Okay, the outbreak of the disease has resulted in 2 death cases and 20 others show symptoms of being infected by the disease, what action should be taken by the hospital for the patient suffering from this epidemic? Justify your answer. So this one is actually, let's say now, okay, we already know the coronavirus. Okay, so what should we did? Okay, so the answer should be we should be quarantine. Okay, so quarantine the patient will be infected. Okay, so we put the people who got the, let's say for now you got the coronavirus, okay, put it in the hospital. Okay, so we didn't let them mix with the community. Okay, so because it will separate, right? Okay, so quarantine the patients will be infected. So this is to prevent patients to interact with community. Okay, so this is the action that you should be take. Okay, all right. The next one. Okay, so the dengue hemorrhagic fever is a contagious disease that can be fatal. So explain how the disease can spread. So when an Aedes mosquito bites, okay, and sucks a patient blood with dengue virus, okay, this infected mosquito will transfer the virus to other individuals. Okay, so let's say let's say the one patient already got the dengue virus, okay, and then the Aedes mosquitoes, it will be bites and sucks the person that has the dengue virus. So now, okay, the Aedes mosquito, okay, has a dengue virus, okay, and then it transferred to the other people, okay. So let's say he go to another people, okay, he sucks the blood of the people. Okay, so means now it transfer the dengue virus to other people. So that is how the disease can spread. Okay. Alright, so let's see next slide. Okay, so magnet. Alright, so properties of a magnet. Okay, so you might already know one of the properties of a magnet. So it can only attract magnetic material. So usually magnetic material is such as a metal. Okay, so do magnet have other properties? Okay, so properties of magnet is attract magnetic materials and it has a poles, okay, north pole and south pole. Okay, and also it's a freely suspended magnet shown north-south direction. Okay, usually the magnetic field will go from the north to south, right? So like poles repels, unlike poles attract. So not, if let's say not meet north, it will repel. Okay, if not meet south, it will attract. Okay, different pole will attract, same pole will repel. Okay, so magnetic fields. Okay, so for photograph 7.14 show only steel balls that are closer to the magnet are attracted by the magnet. So the area around the magnet with the magnetic force is known as magnetic field. So this area, okay, where the steel ball is attracted to the magnet, this area we call it as a magnetic field. Okay. Alright, so this is the pattern of the magnetic field. So you have observed different pattern of magnetic field produced by the magnetic field lines. So this magnetic field line has several characteristics. So when you draw the magnetic field for the magnet bar, okay, so this is called as a magnet bar. You can see the magnetic fields, okay, goes from north to south, right? North to south. Okay, the direction of the magnetic field. Okay, and then the knots go out. Okay, the south. Okay, the magnetic field lines go in. Okay, and then another one is the magnetic field line never met or across. Okay, you can see the line is not cross each other, right? And then the third one is the magnetic field line are closer to one another, where the magnetic field is stronger. Okay, you can see here this area. Okay, the magnetic field line is closer to each other. So mean this one, the magnetic field line is very strong here. Okay, so this is the three characteristic. Okay, when you draw the magnetic field. Okay, you have to know that it moves from north to south, and also it does not cross each other. And also this one, Okay, at this area the magnetic field is stronger. Okay, alright. So electromagnet. Okay, so you have studied electric current in 7.1. So this one is actually from two topic. Okay, so do you know that electric current has a magnetic effect? So an electromagnet is a type of magnet that has a temporary magnetic effect when the electric current flows through it. Okay, so let's say I have one conductor here. Okay, one conductor, and you let the current flows through the conductor here, or this one is a wire. So let's say a wire here, okay, and you let the current flows, okay, through the wire. So around the wire here, okay, the magnetic field will be produced. Okay, the magnetic field will be produced. Okay, and this is called as the temporary magnetic fields. Okay, so let's say if you stop the current, and then this one will not become the electromagnet anymore. Okay, only when the current flows through it, it will become electromagnet. If no current flows through it, means they become there is no magnetic field produced here. Okay, so electromagnet is type of magnet that has temporary magnetic effect when the electric current flows through it. So the electric bell is the object that uses a electromagnet. So this is the example of the application of the electromagnet. Okay. So the pattern of the magnetic field depends on the shape of the conductor used. Okay, for example, the magnetic field line produced by a straight wire and a coil wire are concentric arctic circles. Okay, magnetic fields. Okay, magnetic fields lines are closer when the magnetic field is stronger. So we already explained to you that the stronger the line of the the closer the line of the magnetic fields means the magnetic field is stronger. Okay, like this one. Okay, the closer means the magnetic field become stronger. Okay, so the strength of the magnetic field reduced and move away from the center of the conductor. So the pattern of magnetic field produced is not affected by the direction of the current flows through the conductor. Okay, so the direction of the magnetic field is determined by the direction of the electric current. So this we use the right hand grip rule. Okay, so right hand grip rule determine the direction of the magnetic field of the current flows in the straight wire. Okay, so this is called as a right hand grip rule. So what you do is, so let's say this is the wire here. Okay, you grip the wire. Okay, so this one the question, this one the diagram. Okay, it shows that the current is go upward, right? So mean your thumb also must go upward. Okay, the thumb also must go upward. Okay, and then you can see here, right? Your other fingers will show in this direction, right? They say you grip a wire there and then the thumb is go up. Okay, so the direction of the other fingers here, right? So because it move like this way, okay, so it will move like this. Okay, it move anti-clockwise, right? So it will move anti-clockwise. Okay, so alright. Okay, for like this one. Okay, so this one, direction of current is go upward. Okay, and then this is straight wire. So you grip the wire. Okay, you grip the wire. Okay, you can see your thumb should be upward. Okay, because the direction of the current is go upward. So your thumb must go upward. Okay, and you can see the direction of your other fingers. Okay, it will be like this. Okay, so anti-clockwise. So let's say if the direction of the current going downward like this. So if going downward, okay, so you grip the wire and your thumb is going downward, okay. So your thumb going downward. So you can see the direction of the other fingers is go this way, right? Go this way. So mean is clockwise, okay, it's clockwise. Okay, and then for this one, so this is a coil wire. Okay, so let's say the current flows from here to here, right? So for this okay, for this area, okay, the currents go up, correct? The currents go up. This one, the current go up. Wait, I draw for you. Okay, this one, the currents go up. This one, currents go down, right? So when it goes up, you use the right hand grip rule. So when currents go up, so like this, right? So you can see it move in the anti-clockwise, same like this one, right? You move anti-clockwise. So you see you grip, right? You grip in this area. You put your hand here and you grip it, okay? Okay, and then you can see it goes upward like this. So means your thumb is going upward, and you can see other direction of your fingers is going anti-clockwise like this. Okay, alright. For this one is going downward, means your thumb is going downward. Okay, and then you can see the direction of the current is go clockwise. Okay, and here, right? So I let's say I put the direction here, and this one is like this, right? Okay, like this, and this one is like this. Okay, you can see here at the middle here, right? This area, the direction is same, right? For both magnetic field. Okay, for this one and this one, right? The direction here is same at the middle here. So mean here, the magnetic field also will be in this way, same as this one. This one go upward like that. Okay, so the direction here must also follow. Okay, so this is for the coil wire. Okay, alright, for this one is a solenoid. Okay, solenoid is actually the coil of wire. Okay, we arrange it in the coil, okay, in the coil form. Okay, so this is the, let's say this current is like from here, okay, from here, okay, and then okay, it's have a coil here, it will move like that, right? Okay, so the first one, current in, okay, so like this, okay, so I draw for you. So this is the current, okay, the current flows, okay, right? So here the currents go up, right? The currents go up. Okay, so use the right hand grip rule. Okay, right hand grip rule. So the currents go up. Okay, the currents go up. So means it anti-clockwise. So you can see here the line here is like this. Okay, and here, okay, the currents go down because it's go here and here, right? Go down. Okay, it go down here. So when it go down, okay, when it go down, okay, you use the right hand grip rule, okay, it will go clockwise, okay. Wait, I show you one video. Okay, actually this one we learn in physics form 5. Okay, physics form 5. Okay, I make actually video for form 5, but we use the same method like this. Okay, so wait, I show for you first. That one is much clear. You can see how we use the right hand grip rule. Okay, wait. Okay, wait. electric fields are produced by electrically charged objects. So any object that has charge, usually they have a electric fields. Right, number 4, a ball magnet produces the magnetic fields around it. Right, so this one you have to draw the pattern. So I will show you how's the pattern of the magnetic fields around a ball from knot. Right. Okay, so this one is actually the pattern, okay, that I already draw, okay, for you. Okay, so this one actually we already know the knot go to the south. Okay, if you put compass here, okay, we go to the right, right? We go to the right. Okay, so this is how we draw the magnetic fields to south. Okay, so and you can see. So what I want you to see is actually the right hand grip rule. Okay, right. So the first thing you have to draw the current. Okay, the current flows from the positive terminal to the negative terminal. Okay, from the positive terminal to the negative terminal. Okay, so this is your hand. Okay, so you see the current goes up, right? So mean your thumb here must go up too. Okay, so when it goes up, you can see, right? Your other fingers will show to the anti-clockwise direction. Okay, so as you can see here, it will go anti-clockwise. So mean this one you have to add error here. Okay, so we go anti-clockwise. Okay, so this is the right hand grip rule. So what if we change the terminal of the battery? So let's say this is a positive and then this one is negative. So means the current will flow from positive to negative, right? From positive to negative. Okay, so means, right? So the current is going down, right? So when the current goes down, so this is your right hand grip rule. Okay, so it goes down. So when it goes down, you can see it rotate clockwise. Okay, so mean this one clockwise is here like this. Okay, so when you draw arrow, so it will be like this. Okay. Okay, by using the right hand grip also we can determine, right? Line. Okay, so this actually, this one is not your level. So what I want you to see is, let's say for a coil here. Okay. Okay. So this is for a coil. Okay. So right, if goes out, okay, so if the current goes up, so using your right hand grip rules, okay, so it is anti-clockwise. So before this we learn about only the straight current wire. So what if the currents go down or go inside to the paper? Okay, so it will be clockwise, right? So clockwise will be like this. So this is for the straight current wire. Okay, this one is for the straight wire. Okay, current for the straight wire. Okay. So what if it a circular coil? So like this. Okay. So first one, okay, you must know the direction of the current. So from positive to negative. So from positive to the negative. Okay, so positive
positive to the negative. Okay, right. So we see this side first. Okay, so you see the current goes up, so it will be anti-clockwise. So here you draw the current that are anti-clockwise. Okay, so anti-clockwise like this. Okay, alright. Okay, alright. So see this side after that. Okay, so this one is goes down. Okay, so it clockwise. Okay, clockwise. Okay, clockwise. Right. Okay. Alright. So you see this is the magnetic field for the bolts, right? So this one is going up and this one is going down. So what happened to the center here? Okay, so as you can see the direction is same, right? Both is go up. So in the middle, the line will also, the magnetic field will also go up like this. Okay, so this is magnetic fields due to the current in a circular coil. Okay, so remember,
Okay.
up goes down, goes
Okay. So
up.
that one is for circular coil. So what happened in the solenoid? Okay. So this is the solenoid.
Okay, so because it's a coil, okay, like that, okay, like that, right, like that. Okay, so you see the first part here, so here first, right? So this one you can see the current is goes up. Okay, when it go up, so you see it is a anti-clockwise. So you draw a line here. Okay, you draw a line here like that. Okay, so anti-clockwise is like this. Okay. For this part, okay, here, see the line, the direction is same, right? Okay, so we draw this part. Okay, so this part using the right hand grip rule, side goes down like that, right? So it go down like that. So mean this is a clockwise. Okay, so you draw clockwise. Okay. So what happened in the middle here? So you see the line, the direction is same, right? Goes to the left. So means before, okay, we see also the middles, okay, it follows the direction, right? So the between is between. So the between, the line between is goes to the right. Goes to the right, to like that. Sorry, to the left, not to the right. Okay. So this is the magnetic field for the solenoid. I will show you the proper one. Okay, right. So because now my hand, which one is sub, right?
Okay.
We always show not.
Right. So that is actually. Mm, okay. So I hope you can understand okay better, right? How did you get the pattern or direction of the magnetic fields? Okay. So for the straight wire, why it become like this? For the coil, why it become like this? And for the solenoid, why it become like this? You just use the right hand grip rule, okay? And the direction of the current, okay, you just follow your thumb, and your thumb must follow the direction of the currents, okay? And then your other fingers will show the direction of the magnetic fields, right? So this is the pattern, okay? Right, so let's go to the question, right? So if you want to see the video, actually that video is also in my YouTube channel. You can see it if you want it to see again, so maybe more clear. So diagram 2.1 shows a bar magnet, right? So state two properties of the magnet shown in the diagram 2.1. So the first one is interact the magnetic materials and also has a magnetic poles. Okay, so this is the properties of the magnet. Okay, we discussed that. Alright, and then the next one, diagram 2.2 shows a magnet with its magnetic fields. Okay, so name the force that exists around the magnet. So the force that exists around the magnet is called as a magnetic force. Okay, and then next one, explain the pattern of the magnetic field in diagram 2.2. Okay, actually the answer, okay, is come from this. Okay, so the patterns of the magnetic fields, the first you can choose, okay, they got three here, right? So you can choose two of it. Okay, so the first one, maybe the magnetic field lines never meet or cross each other. Okay, and then the magnetic field line must from the north to the south pole. Okay, and the closer the magnetic field line means it shows it has a stronger magnetic fields. Okay, the closer the magnetic field line, okay, the stronger the magnetic fields. Okay, so you can choose three of these, okay, as your answer. Okay, but this one, 2 marks mean you can only put two lah. Okay, two pattern. Okay. Alright, the next one you have to compare the magnetic fields at P and Q, right? So P and Q here. So here you can see the magnetic field line is much closer than here, right? At P is much closer at Q. So means the magnetic fields at P is stronger. Okay? Right, next one. So diagram 2.3 shows a tool made from a magnet. So name the tool in diagram 2.3. So this one is actually a compass. Okay, compass. Right, the next one, state the property of the magnet used in this tool. So the needle will always pointed to north-south direction. Okay, so the compass, usually the needle will always point to the north. Okay, so that is the property of the magnet that we use, okay, in the compass. Alright, diagram 2.4 shows a simple electromagnet solenoid. Okay, so what is an electromagnet? So electromagnet, as we discussed before here, so what does it mean by electromagnet? It's a temporary magnet. Okay, so it becomes temporary magnet when there's a current flows through it. Okay, so that's the answer. Okay, okay, temporary magnet, okay, that has a magnetic field when the current flows through it, right? Okay, for this one, draw the direction of the current flows in diagram 2.4. Okay, so you have to draw the direction of the current flows. Okay, so you know the current flows from positive to negative terminal. Okay, so you draw the line here. Okay, so it will go like this, right? Okay, and go like this, like this, like this, okay, and it will go down like this. Okay, so positive, because it's a coil here, right? So it will be like, okay, rotate like this, right? Okay, so draw the direction of the current flows in diagram 2.4. So this is the direction of the current. Okay, all right. So I think there's another question, right? I think maybe they got another question. Wait, I check this. Because they give a magnet here. So must be a question. No. Okay, you only have to draw the direction of the current here. Okay. No. Alright. So draw the direction of the current flows in diagram 2.4. So the positive to the negative. So this is the answer. Okay. Alright. Okay, next one. Okay, next one we see about relationship between temperature and heat. Okay, so try to recall the knowledge of heat and temperature that you have learned in primary school. So heat is obtained from various sources such as sun, electrical appliances, and burning of the fuel. Okay, so what is heat? Heat is a form of energy. Okay, so heat flows from the hotter region to colder region. Okay, so what does the temperature mean? So temperature is a degree of hotness. Okay, of an object. Okay, degree of hotness of an object. Okay, so temperature increase in the hot environment and decrease in the cool environment. Okay, so what the apparatus that we use to measure the temperature? So we use a thermometer. Okay, so this is the example. So let's say if you boil a water, okay, to cook the spaghetti here. So when the water is heated, the temperature is increased, okay. And this one, so if you put the drink in your freezer, so this there will become ice, right? So this one, the temperature will be decreased, okay. Alright, next one, okay. Although heat and temperature are interrelated, both are not same. So we have to know there's a difference between heat and the temperature. Heat is actually a form of energy. Okay, the temperature is actually the degree of hotness or coldness of an object. And heat we measure it in joule. Okay, measure it in joule. Energy, the unit of energy, okay, usually must be a joule. So I think you already learned in Form 3, right? For the gravitational potential energy, for the kinetic energy, okay, all of it use the joule, okay, as a unit. So heat also the unit must be in joule. Okay, and then the temperature we use the Kelvin or degree Celsius. And heat is actually the amount of heat depends of the type of material, quantity of the material, and temperature. Okay, but the temperature it depends on the degree of the movement of the particle in the metal. So this one is actually using the kinetic theory, kinetic energy theory of the particle. Okay. Alright. So next one. So heat flows and thermal equilibrium. Okay, so we already know that heat flow from the hot object to the cold object. Okay, so heat flows in the three different way. Okay, such as conduction, convection, and radiation. Okay, so heat flows. Okay, it happens in three different way: conduction, convection, and also radiation. Okay, so we see one by one. So conduction, what is the conduction? Okay, so the conduction is a process of heat transfer from hotter regions to colder regions through a solid medium. Okay, through a solid medium. Okay, not liquid, must be solid. Okay, solid such as metal. Okay, so the particles that receive heat energy will vibrate and collide with one another more frequently and transfer the heat to the whole medium. So let's say this is the example. You know solid, the arrangement molecule of the solid, they are very close to each other like this, right? So let's say if I heat this particle, okay, this particle. So what happened? So when you hit the particle here, when you hit the particle here, this particle will vibrate. So when it vibrate, it will collide with next particle. Okay, and this particle will also vibrate, right? And then it will collide to the next particle. Okay, and then it will vibrate. Okay, so mean it transferred. So the energy will be transferred. Okay, when it's vibrate. Okay, while it's vibrate and collide to another particle. Okay, the heat also will be transferred. Okay, so the direction of the heat flows will be in this way. Okay, so conduction is the process of the transfer of heat, okay, from a hotter region to the colder region in a solid medium. So you have to remember must be in solid, is such as metal. Okay, metal is solid, right? So this is how they transfer the energy. Okay, so because the arrangement of the molecule is very close, so it just vibrate and it vibrate collide with another molecule, and at the same time they also transfer the energy. Okay, so this is called as a conduction. Alright, the next one is the convection. So this one, the heat is transferred by the movement of the fluid, okay, so such as liquid and gas, from hotter regions to colder regions, okay. So the part of the fluid that receive heat will expand, okay. When it expand, it become less dense and rise. So the colder and more dense liquid move downwards, okay, and the circulating stream that rises and falls continuously is known as a convection current. So let's say if you boil a water here. So when you boil a water, of course, this below part, okay, this below, okay, this below part, it will be hotter, okay. So when it hotter, the particle here will expand, right? So when it expand, it become less dense. So the less dense, you will be, the less dense object will be floating, right? It will go upward. And this one at the upper part is colder, okay? So it will go downward because it become denser now, okay, compared to the below part, okay? So I repeat, at the below part, right, it will become hotter and hotter, and then the molecule, the particle will expand. So when it expand, the density will be lower, okay? And you know the density lower, okay, there will go upward, right? It will float, okay? So it will go upward like this, okay? And this one, okay, compared to the upper part is cold, right? So cold means it's denser than the below part, so it will go downward. Okay, so we go downward, then it will be heated by the we heated here, so then there will be like a convection current here. This is called as a convection current because there's direction of the flows of the particle here. Okay, less dense go up, less high dense go down. So you will produce the convection current here. Okay, it will circulate, right? Okay. Alright, next one is the radiation, the process of transferring heat without any medium. So this one we don't need any medium. It doesn't need any particle, vacuum, right? Because the heat can propagate through an empty space or vacuum. Okay, the type of surface, temperature, and total surface area an object will influence the rate of heat flow. Okay. So mean here the type of surface, let's say the type of surface is smooth, right? So smooth, so means sorry, not smooth, shining, right? So when it's shining, so mean it can absorb more heat here, okay? Or the temperature is high, right? Or the total surface is bigger. So when the total surface area is bigger, mean it can absorb more heat. So the radiation will be increased, okay? So conduction, remember conduction is only for solid, okay? That's solid and it transfer by the vibration of the molecule from the hotter to the colder particle, okay? And then for this one, convection is actually for fluids such as liquid or gas. Okay, I already explained at the bottom part, it become hotter, so it will expand and become less dense, so it will go up. Okay, and then at the upper part is colder, so it's high dense now, so it will go down. So you can see there is a flow here, one go up, one go down. So means there is a direction here. So the direction, the circulating, it will circulate, right? So when it circulate, it will produce the convection current. So that is called as a convection current. And radiation does not need any medium, so vacuum. Okay. And also this example like sunlight. Okay. Sunlight is actually a example for the radiation. Okay, because you know outer space there is no particle. Okay, but we can still feel heat at the earth here from the sun. So means that one is from radiation. Okay. So this is the three type of how the heat be transferred. Okay, so let's say you go to the beach. Okay, so sea breeze, right? So what is the sea breeze? Okay, so the formation of the land breeze and sea breeze are example of natural convection process. Okay, alright. So let's say okay, at the land here. So at the land, let's say at the morning. Okay, so during the daytime, right? So during the daytime, the land will heat up faster. Okay, so the land will heat up faster. So as you know, right? So like this also, like this one also, when it heat up, it expand, it will become less dense, so it will go up. So same as here, but this one is liquid, right? But this one is for air. Okay, so they say it heat up faster, so the air at the bottom part here, okay, near to the land, also will be heat up. Okay, so when heat up, it become less dense, so it will go up. Okay, it will go up. Okay, so at the daytime, the land heat up faster, so the air near the land here, it will become hotter also, and it will become less dense, so it will go up. Okay, okay, and then the here it's cold here, right? Compared to here, this one is more cold. So this one, the cold air will move toward the land here. Okay, we move toward the land here. Okay, so this is what we call as sea breeze. Okay, so the explanation is during the day the sun heat up land faster than the sea. So warm air on land expands, become less dense and rises because it is lighter. Okay, so the cool air from the surface of the sea that is more dense is drawn in to replace the warm air on land. So the result is sea breeze. Okay, so this one become hot, can become hot. The air near to the land become hot also, and we expand, become less dense. It will go up. Okay, this one is higher density. It will go towards the land here to replace the air that already go up, right? Okay, what happened during at night? So at night, okay, the land cool faster. Okay, so this one, it become hotter. Okay, this one the land cool faster. So this one, the warm air here, it become the at the sea part here, okay, it become hotter compared to this one. So warm air will go up. Okay, warm air will go up. Okay, because it's hotter here means less dense. So the air will go up, and then this one, the cold air will move downward. Okay, and then it goes to the sea here. Okay, to replace the warm air that already go up. Okay, so at night the land cool faster than the sea. The air above the sea, which is warmer, become less dense and rises. Okay, the cool and more dense air from land begins to move to the sea, resulting in the land breeze. Okay, so mean the air from the land is goes to the sea here to replace the warm air that goes up. Okay, so this is called as the land breeze. Okay, so I think I stop here first. Okay, so we continue, right? Next class, the next lesson. Okay, thank you class.